Welcome back. This video is going to explain and describe diffraction. Here you see an aerial photograph of a little inlet through which the water waves are moving. Now here you can see the crest of a straight wave coming in towards. Here's another one. I can make out about 3 crests of water waves moving towards this inlet to this little bay. And it's very, very apparent that the straight waves are actually bent after moving through the gap between the rocks there. Now, you might think that the bending is because of this roundish beach here, but that is not the case. The bending is because of the diffraction taking place as the wave moves through the gap in the rocks. You wouldn't believe your ears now, but when the sun shines through the clouds, there are gaps in the clouds, and you see dark lines and light lines in the sky. Now, I also grew up thinking that these light and dark lines are due to the shadows cast by the clouds, but they're not. They're actually a natural occurrence of interference as the light moves through the slits, or like you can say, the gaps between the clouds. Interesting, huh? Now, we can't really see into a substance like sodium chloride, but if you use X-rays, you get a diffraction pattern caused by the X-rays moving between the little atoms. So they actually interpret the photos that they take using the X-rays, and the diffraction pattern shows scientists exactly where the atoms are. Interesting, eh? Now, the conditions for diffraction is that the obstacle or the gap that is in the way of the wave must be around about the same wavelength as a distance as the wavelength of the waves. The definition of diffraction: it is the bending of a wave around the edge of an object, or when the wave moves through an opening between obstacles in its path. Now, the person that played a very important role in developing this theory around diffraction is Huygens. The first or primary wavefront creates a second wavefront, which in turn results in a third wavefront. Huygens maintained that each portion of the wavefront acts as a new source of a circular wave, and I'm going to explain this on the next slide. Here we have a diagram showing how a wave is nearing a gap in its path. Now, when that wave front gets to the gap, part of the wave is blocked but another part of it will move into the gap. Now, to explain the bending of the waves, Huygens said that each point on this wave front acts as a source of a circular wavelet. So let's try and draw in a circular wavelet there, and another circular wavelet there, and another circular wavelet there, and another. I should actually be drawing them to show the wavelength. So that distance between the wave crests there is a wavelength. So actually my circular wavelets should have the same wavelength. Now, the new wave front will be formed by the tangent between these little wavelets. Remember, they move out forward in the same at the same speed. So you'll see that the waves are bent as they move through the gap. So in reality, Huygens' principle says that every point on a wavefront acts as a source of tiny wavelets that spread out in a forward direction at the speed of the wave itself. The new wavefront is the surface that is tangent to the wavelets. Due to the lack of interference between the wavelets, the wave bends around the edge of the obstacle in its path because there is no more wavelets for it to interfere with. This video you can watch on YouTube, and it explains diffraction and interference beautifully, so enjoy.